If I'm pulling it down, now the question is, what's the direction of really the normal force? So this is pushing down on here, like we have it drawn here, that we've got this normal force the table called exerts on the table. If you're pushing on the edge here, you potentially have another normal force that is actually acting there at the edge, which would try to make the table move back that way, which then would put potentially friction in this direction. So, how do you deal with it? How do you read my mind on that? One, hopefully I've drawn it so that that's not an issue. But the way I've drawn this one, potentially it's an issue. If I mark off on it, then when you get it back, just come up to me and say, here's my reasoning of why I think my answer is correct. So.
You drew a little piece over the table, is that what you're talking about?
Yeah.
Okay.
The intent was that it's really coming straight off like this, and so I'm not worrying about the normal force on the corner right here.
Yeah.
However, I can't remember the exact way I drew it.
No,
So-
it's coming off a little bit. You have the tablecloth like extended over the table.
Yeah, so potentially that's my bad.
So that would be when you had another normal force?
Yeah, or you would adjust the one normal force you've drawn on there. Trying to find the original drawing.
Or maybe you just drew the arrow. It kind of looks like an arrow.
Yeah, I had not thought about it when I wrote the problem. So, it's the type of thing that there are multiple interpretations sometimes, and sometimes we get a long paragraph for a problem. When I'm going through my head as I write it, I think, all right, this is the way I want them to answer it, so let me throw in all this extra stuff just to eliminate all the stuff I don't want to worry about. I don't always get it. Sometimes I put too many words in there and it just really messes with people's heads as opposed to the, you know, if I kept the simple wording, most people would answer it still the same way, but then there's gonna be that one person who thinks differently. Not there's anything wrong with that, but it's a hassle when I'm grading, when I suddenly have to go, oh, well, I guess either answer is correct. I'd like there to be an answer. Like life, there's an answer, right? So in a case like that, where there's multiple interpretations, during the test, come up and ask, and afterwards, just make your case for why you're correct. And since it's physics, just assume that you're right and I'm wrong. And then we'll settle it like physicists with a knife fight. It kills some of the physicists I've known. It just makes me laugh to think about them in a knife fight. Anyway, Jasmira,
Are we done with this course diagram?
are we done?
Oh, I'm not sure.
Any other questions?
As long as there's no other, yeah.
There is no other.
Okay, cause I had another one of, if you could do one of two houses on the wall. Of the friction between those two, one sliding down and the other one keeping on.
Alright, so we had a wall here, and then, I forget which was box one, box two. The force on box one, was it up at an angle or straight across? Angle.
Could I ask a question really fast about this? I'm so sorry, I forgot. On one of our homework questions, on number 60, you did actually ask for the earth, let me see if I can say this right, the earth pushing back on someone. Are you gonna require that in the exam? I didn't word it correctly, but it's this problem.
Two interactions involving the spin around. So, alright, so what's your question again?
So are you gonna ask for this one? Because you didn't do
Oh,
it
the
for any
gravitational
of
pull?
those. Yeah, because it's
Well-
so small, would you want us to
No, I
put
mean,
it on
because
here?
that's between the stone and the earth. That's the weight right there. That, what you have labeled as capital G, that's just the weight of the object.
Right, so you didn't want this at all?
Oh, the G subscript?
Yeah.
No,
No, not the G subscript, but the pull upwards.
I would want that, and we did that here too. that's what these are. That's the pull upward.
Oh, so it's not the minute one that you keep talking about, that doesn't matter?
The
Like
minute
our
one is
force-
between the small objects, small relative to a planet.
Okay, of like us pushing down on the earth.
No, that would be a normal force there. The small one of the gravitational force between you and Abby,
Yes.
that's
yes,
the one that you can ignore.
Okay, so we're not gonna have to put that at all.
Right,
Okay,
not here.
alright.
Okay,
The
Thank you.
people who actually care about that stuff are the people who do the gravitation experiments.
Okay.
On my
We're not those
dissertation,
people.
no, we are not. In my dissertation, I did not worry about the gravitational pull between any of the objects.
Okay, thank you.
so if I'm writing about that, I can say like no gravitational forces, cause sometimes I write like no significant, just cause I know that there is a small gravitational force. Can I just write there are no gravitation, like there are no forces other than that?
Well, I like the fact that it's no significant forces. If you wrote no gravitational,
Like there are no other forces acting on, like if I, like let's say I throw a ball up in the air, once the ball leaves my hand, there are no forces between my hand, there are no more forces acting on the ball.
yeah,
than
I'm
gravitational
fine
force
with
on the
that.
floor.
No more forces between your hand and the ball,
Okay.
even though there's some tiny,
Yeah,
order of 10 to the negative 20th newtons at best.
Thank
Your
you.
phone went out.
okay, thank you.
Pardon?
The camera.
Oh, it's got issues again?
Well, it's like you understand.
Oh. It's about to lose power.
Yeah, can I see the screen?
Suddenly there's a big shift. Oh, is that 4%? Thank you. All right. Where I think we were ready to answer the other one, was it?
Yes, thank you, sorry to drag you back.
No problem. All right, so the scenario that's going on here, I have managed to recreate this occasionally. Let's see how the coordination's working today. So I've got basically two objects, and I'm pushing on it like that. Because I think the one that I'm pushing on, this one right here, is going down relative to the wall, but going up relative to the middle one. Just like right there, they both were coming down, but this one was sliding faster. So this question was about when you're trying to determine the direction of the friction, it's relative to what? And the big thing here is it's relative to what it is touching. Not relative to the wall, but relative to this. So if this is falling faster than this is, in other words, this is moving up relative to that, friction opposes that. So from this point of view, from the point of view of the middle one, this thing is moving upwards. So friction acting on this will be down. And so you'll have, that'll be up like this. This is going down relative to the wall.
Okay, I get it, because that's, okay, so box 2 is acting, well, box 1 is the first one.
That's one.
Yeah, and friction is acting up on box 2, but box 2 is, friction is acting down,
Yes.
basically. Okay.
And in this particular case, as this thing is falling faster, I can feel this dragging on the book downwards. I can feel that drag. And by the way, students rarely do this, but I have had students on that, especially on the multiple choice, my first year here, I had a student who was conducting little experiments at his table, at his desk while he was taking the test. I have no problem with that. As long as you've got the resources around you. Or if you need to borrow a box to run a quick experiment, go for it. I don't know if it'll help you on this test coming up. I try not to write my test till the last minute. Let's make this sort of the last question for now, because I do want to talk about the lab.
Everyone.
Oh, no, I wanted to make room
No,
for
I
it.
was wondering if you, but I could wait till like Tuesday, if we could do like some examples from the beginning when we started class, cause I know I done got a lot of that information by now.
Okay. I will go however you want to do it.
Yeah, I'll wait till Tuesday.
Okay. All right, let's talk about today's lab. Feels awkward now to do this, but sorry about that. All right, so today's lab is a momentum lab. So the topic of what we're doing today is not part of the first test. If you've seen the videos at this point, you know what momentum is. But the symbol for momentum is the lowercase p, so this is momentum. Actually, momentum of an object is a lowercase p. Typically, you use the uppercase P for momentum with the vector symbol, if you're talking about the momentum of a whole bunch of stuff. And that's mass times velocity. So when doing the experiment, recognize that momentum and velocity are not the same thing. I've had many students who used the term momentum when they meant velocity and vice versa. So part of the exercise in the very beginning of the lab is to try to get you to think about the difference in the vocabulary that you're using. Also, some of you still seem to confuse acceleration and velocity. Those are very different. Acceleration deals with the change in velocity. Velocity is just how fast you're going in which direction. The content of the lab, this is probably the least quantitative lab that we do. There's a whole lot of descriptive words that you'll be using. Just please be careful with how you word things. Now, it is okay if the group hands in one group could hand in one momentum lab, and it'll count for all of you. If you don't like what's being written, feel free to submit your own, but if you don't, then whatever the group one is, that's the one that's going to give you your grade. So watch out for vague terms. I think at this point on the first page where I have warnings or notes or something like that, where I talk about some of the common mistakes that I see. If you do not finish in time, there is, I think I had a link to the video of my doing the lab. So you can always sort of back up and resort to watching my doing the lab as a way of getting the last pieces. That you aren't doing any measurements, it's just a matter of observing and describing things properly. So we've got 7, 10, 16. Let's try 4 groups of 4. Now the tracks are back there to the right of the table over there. I guess the table closest to Abby, or the desk closest to Abby, just to the right are the tracks. The carts are over here and about this high on the far right. There are 2 types of carts over there. One are with plunger and one without. Unless it's gotten messed up, you should be able to grab one of each, and one orientation will have them repel, another orientation will have them stick together. If you happen to grab one of each and it's not like that, then let me know, or let me know. Probably the simplest is to get another one that will work, or I can switch the magnets around if I have to. Just that takes me a couple minutes to switch the battery, flip the batteries, magnets around, not batteries. And I think with that, I will get the face shields. And we will commence with a rejoicing, because, this is physics. Please.
Thank you.